In the meantime, we've got a really cool talk. This Kristaps. He's actually all the way from Sweden, correct? Okay, I get confused because he does work for the BSD LB project in Latvia, but he's from Sweden. You went to school?
Yeah, I can't go anywhere.
Okay, great. Actually, I've got a couple things, but we'll catch that afterwards. Okay, thanks.
Before I get started, I wanted to thank Jason for just organizing a very nice conference. I think we're all enjoying ourselves.
Absolutely.
Unless anybody isn't. So we can.
We actually took care of those people yesterday.
All right. So everything worked out. Because I don't see the faces that, nobody will be seeing for a while. So anyway, today I'm going to be talking about process isolation. And before I begin, I want to have a little survey of what people have used here so that I know what to make fun of and what not. Last time we had kind of problems, so I want to avoid that and be a little bit more politically correct. So who here has used Zen? Zen. What about Zen on NetBSD?
Usually press that.
What? Jesus. All right. Well, one guy is a brave soul. What about vServer on Linux? Yeah, nobody is fool enough to raise their hand, but I know there's some of you, right? What about?
I wouldn't admit running Zen either.
Yeah, it's the same guy who's running vServer also. What about jail on FreeBSD? All right, so you're most familiar with jail and basically how it works. Who really has no idea what jail is or anything that I've said? At your own peril.
No
You really want to?
conviction.
What's that?
No conviction.
Yeah, no, but if anybody doesn't know, this is the time to say it so that I can be a little bit more slow when I get into it. And fast. All right. So what I'm basically going to talk about is something like that, but for OpenBSD and NetBSD. Some of you may have already heard of this, and it's been around in various guises for about, I guess about a year and a half now. This is the latest edition of it, and I've gone through NetBSD and doing OpenBSD, and now doing both of them at the same time. So the focus of this is going to be a demo that's going to be about halfway through this, a little bit more than that. That's where I want to show off what it does. This is not like an idea, it really works. It's out there somewhere. When I actually do the demo, I'm going to have to do SSH and everything, so things may take a few seconds. I assume everything's going to fall apart. It's actually very, very live, so don't, be angry if...
Assume the worst, you won't be disappointed.
Exactly. I'll cry a little, but, if anybody has seen my conferences before, that's nothing new. So anyway, let's get started. What this is based on... so I see it already broke. There we go. Mult is the basic idea. I'm not going to bash Mac now because it's now running on it. So, don't bite the hand that feeds. It's great. It's fantastic. I should disclaim that the reason I'm not using my own laptop, I have to say it because I got such flack from it, is that I run OpenBSD-4.4, so I don't have WPA. I'm sorry if that offends anybody. There's now murmurs in the crowd. People are leaving. Anyway, this is called Mult. The website is there. Fortunately, none of you can see it right now, so you're not going to all go to it and forget about me here. The Anon CVS is there. All the instructions you'll need if you actually get to the site are all there on how to download things, look at them. There's Web CVS. All those goodies are there. I'd like to thank very quickly Michael Dexters, who hosts this on his server in Riga. So he's not here right now. He couldn't be here, but he runs that. Right, so what I'm going to talk about briefly is what this whole thing is based on. And it's kind of many of you may already know this, but I'm going to do it anyway. So basically, when we think, this is my work computer, when we think of running a computer, right, we basically have a computer and we have an operating system running on it. In this case, I'm going to use OpenBSD just because the image had a transparent background and the NetBSD one didn't. So, I'm really not, I'm not going to be biased here. That's just a simple matter of fact. So NetBSD people get the transparent background, so it looks pretty. Again, yeah, they really got to upgrade, but that's fine. And basically, as we all know, this is what it looks like. If you guys want me to be more in-depth, just raise your hand and ask. I really like interruptions. If you are thinking of it, somebody else's too, is what I tell my kids. So we have the user land where we're running our processes and our stuff. And then we have things that generally we aren't that interested in, and if we are interested in them, they're probably broken, or you're one of the small core team people here. But there's the kernel and there's the hardware, and for all intents and purposes, they're the same thing. And we're interested with all the good stuff down here, like the browser and email and whatever else people use. I wasn't going to say that. So what I propose, and what all these systems that I talked about before, vServer, Zen, and so on and so forth do, are they let us have many of these work computers inside of one. So in effect, you're multiplying, and which is why I call multiplicity, the system that's in there. So for something like jail, which you're all familiar with, you have multiple user environments in one computer itself, and it's multiplexed in the kernel. Now with something like Zen, which I'm sure you kind of know the idea of, you have the entire operating system.
You multiply the programs.
Yeah. Well, it depends on what you're running as the DOM, right? For Zen.
That only changes what programs you multiply.
Oh well, yeah. Actually, that's true. And then the level and degree and whether it's Linux. So, if we're running vServer for Dragonfly BSD, I haven't heard anybody talk about that yet. But that's apparently pretty cool, and that lets you run whole Dragonfly operating systems. Maybe others inside of userland. I don't know enough about it to say, but
The guy is unfortunately in the next room.
yeah, he's fragging somebody else. So, and here basically we have many userland 0, 1, and 2, and then one hardware and possibly many kernels, possibly not. So this could be where n equal 1. That can happen too, and I'll talk about that briefly, really briefly, because that was previous talks. I'm not going to talk about it today. So that's kind of what it looks like from an architectural standpoint. What I'm going to do now is take you very briefly through what this means to us, computer operators, and when we're writing programs. Who knows how to write C? Fantastic. Only Windows. All right, so we have Windows programming here too. We're taking names also.
Yeah,
All right. My God, get out.
No, that would mean he's managed, and we all know anything is unmanageable.
Oh, that's true.
Oh, this is Microsoft jokes. So this is all basically familiar to us, right? Except usually we're not warning anybody of anything. We just pass. Yeah. But in general, so we have a simple program, and all we're going to do in this program is kill another process. So briefly, I'm going to take you through this. We're going to approach it as we all know it, and then I'm going to introduce what happens in my system, which we'll talk about more when I do the demo, and why it's so fantastic. So once this flips into the kernel, again, my work computer, and again, the transparent background. See, it looks beautiful. And what we have inside of here is actually a snippet from kern sig.c in the kernel. And this is kind of self-explanatory here. We have the system call. Here we're going to find the process structure. I don't have a pointer. I love pointers. If we manage to find it, then we continue and do the good stuff. If not, we turn eSearch.
I see a few of them in the...
eSearches or what? Oh, yeah. That's true. Wait, who did the red thing? Fantastic. This guy saves the day.
Just push on that bit.
All right. I'm not going to point it at anybody, but if anybody makes more jokes. Right, so here at pfind, this is where we're finding the actual process structure. There's a data on what our process is. Without that structure, we have nothing. And we're getting it from an integer, which is a PID. Everybody knows what a PID is. And that's where we get the stuff itself. A number is a number. It's meaningless. And then this we don't really care about right now. So what's important is the pfind, because that's where we get the stuff from. And what pfind does internally is it looks up the process in this big table, does a hash table lookup, more or less, and finds p from it. So there's a big table sitting there in memory, and it yanks the process from there. So my thought was at one point, well, if I wanted to have a process that couldn't be seen by any other process, guaranteed, why not just have multiple process tables? And then whenever I want to look up another process, I have a handle to that table from my process structure. That makes sense, right? Because then we always have a guarantee that nobody else can see into our process table because they'll have their own process table. And that's basically what I did. So every time I have a pfind, I have to pass in from the calling process a handle to my what's called an instance. An instance is your user environment. And with that, I can get the process table from there, transform the PID into a process, and so on and so forth.
So you have overlapping bins?
Yes, I can have overlapping PIDs. That we'll talk about in the performance issues a little bit later. But so in theory, not only can you have overlapping PIDs, you can have overlapping PID 1, the really important ones, kernel thread PIDs. All these we'll talk about into problems. Most people I don't think are interested in that. So at the end of the conference. Yeah, well, the cool people are interested. Yeah. Okay, so that's kind of the meat of everything. Is that in certain functions, instead of just getting something from a global table, we get it from our table. And of course, if somebody else is in a different instance, they'll never be able to see it because they can't hop across instances. It's, that's just not how it works. So essentially, that is going to map down into a structure, more or less. That structure has our stuff, right? The process tables in that structure are linked to it. And of course, in there is all of our open files, open sockets. So these things cascade down. So not only do we have the processes themselves in that table, but everything from them. Process groups, open files, open descriptors, all that good stuff is in there. So once we've taken those processes and grouped them in instances, all sorts of other good things fall into it. So, as an example, this process number right here, if this resolves to a pointer there, all of our user land is basically accessible from that pointer. If there are multiple processes, then they're completely different user lands, all in there right out of the box. So a priori isolation. Very nice. How does that happen, right? It's great to talk about it in the abstract, but it's very, very simple. While a user land process is running, it calls a simple system call, fork inst, just like fork. After that, there's another instance somewhere out there in the world executing. Actually, the semantics of this call, as we'll get to probably at the end of it, are identical to that of fork. If it returns a 0, you're in your child context, which cannot see the parent at all. Your process, more or less, 1. You have no parent.
So you copy all the data and all?
No, I reinitialize it from 0. So it has no shares whatsoever. What's that?
Text shared?
I believe parts of the VM are shared, yes. But in terms of the resources that are available, like your file descriptors, signals, the meat, basically none of that is shared. All of that is reinitialized. So it's basically, what I did is I took the main structure, the function main, did all that stuff per instance. So there's a whole, not only is fork inst in there, but that calls into fork inst 9, which is a clone of fork 1, and that does all the good stuff. We'll get to that later.
So you're keeping the good old tradition of using meaningless function names in the code?
Yeah, and I always wondered that too, but when in Rome. Is there actually a history to fork 1 and everything? Oh my god. Okay, we'll talk about that later. I may beat you up. So, anyway, the great thing about this is that we have multiple of these process tables, and they cannot see one another unless they have a pointer into that. So that's great, because then we have full isolation. They can't talk to one another. So this is actually nice for those of you who are used to jail, because in jail, whenever we want to see into another jail, we do this little fancy can see, in your prison. There's a bit of logic and conditional logic in there, and that's great. But it's a little messy, because every single time we talk to another process, we have to make sure that we can see it. In this, we don't need to do all that. We know that it's in our instance because it's hanging off of our struct proc. So I'm going to do the demo. But before I do the demo, does anybody have any questions?
Yes.
Yeah.
So do you provide IPC mechanisms for unrelated processes?
Right now, it's just proc. It's just struct proc that is appropriated, so to speak. So right now, this is minimal appropriation. And in fact, we'll talk about the previous editions of this. I'll remember who you guys are. It's just so your arms are going to get tired. When I talk about the history of this, I'm going to bring up the first prototype, which was off of NetBSD 3.1. That had everything in it.
You just made that slide to make us feel the beer from yesterday, right?
What are you talking about? Just a simple word. You guys can puke in the corner. Or your neighbor. Depends on who he is. Right. The initial version, which I don't want to talk too much about right now, had everything in it. It had mount lists, it had devices, shared memory regions. Everything was appropriated in instances. With this, it's just pretty much a process table and the process group table, and nothing else. So all of that stuff is appropriated, nothing else is. It's very lightweight. And I'll talk about why I did that, but basically, the 3.1 prototype was so huge. It was a patch that was 1 million lines long, maybe 2, and this is a lot smaller. Yeah. Over there.
Why didn't you just augment construct to have an instance network and just so the APIs to all things would be fine and everything else would have to change? And inside those routines, you could just sort of do the segregation of that.
Well, that's what jail does, basically. And the problems with that is that, this actually I talked about on Asia BSDCon last year, is that that's what I call functional isolation, where every single time you have a conflict point, like where you need to see into another process, you have to enact a little check. Can I see it or not? But you never know if you have all of those points handled. For example, what if in Compat Linux, say, they have a slightly different way of doing it and somebody just forgets? Right? Then somebody can break your jails. Now, what if somebody is using a different way to get to the other process, accessing directly the hash table in future editions of FreeBSD, say? You just have no way of knowing whether that jail is always intact. So the integrity there is not provable. And I didn't mention this, but I work in mathematics. Provability is really very, very important to me. And in fact, I'll talk about some interesting developments that are happening at the University of Latvia regarding this and provable, more or less provable, isolation from the source level. So it's pretty interesting stuff. We'll talk about it later. Right, so that's the answer. Does that answer your question? Yeah, we basically, I don't want to do it every single time I have to check a process can see another process. It's ugly.
It's exactly the right approach.
Yeah.
Just to check it every time is not going to work.
It's fun because you'll miss something, always. And let's say we do more appropriation, like mount lists. Then you have to make sure that every single time you hit the mount list, you have protection there. Every single time you hit that. It doesn't scale.
It's wrong way around.
Yeah, and in fact, this is why FreeBSD jail ran into problems. Let's say host ID. Are you sure that you can set host ID from every single jail in your system? And I know that because that was the example I used last time, at least in FreeBSD 6. So, what does that mean? I mean, that means you have a conflict because one jail can affect the other. Now, that's just ugly in my mind. You want to have things nice and clean and know exactly what is isolated and what is not. And this does that because it uses it logically. If the structure is isolated and nobody else can see the structure, you don't need to worry. Yes?
From the global instance, the administrative instance, can you see everything?
There is no administrative instance. This is fully federated. That's another big difference between jail and this. And actually, this is my favorite difference. Jail has like a big, warden. It's like a panopticon. Right? So you got the warden, right? And the warden makes all the jails. And the jails are the little slaves. We've all seen the Iraq photo. It's bad. We don't want that to happen. So what we do here is we have full federation. Yeah. Oh yeah, we're just a little more rustles in the crowd. Crap kicked out of me later. I'll remember. So essentially, when with again what I call federated because it sounds pretty official. There's a flat namespace. You basically have individual instances. And you can start an instance from yours if you have permission to do that. We'll talk about that later. But you can never see into your children for the most part. So once you start something up, it's gone. Now, I kind of have little tools that let you do that. And again, we'll talk about that later. I augmented PS to allow you to see into another if you have permission also. But for the most part, they're totally separate. So if you have multiple people who don't trust one another on one box, it's ideal because nobody can really see into anybody else. So there's no global person who controls everything, and that was a design decision from the first, because I wanted very full separation on all accounts. I actually can't really see that far, so I don't know whom I'm looking at from here. I know somebody over there. Did I answer your question?
Yes.
All right.
So how many?
Wait, he had something.
He asked half of it, so the other half was, since they're all completely federated,
Yeah.
and kind of hierarchy, how do you go about cleaning them up, reading them? How do you go about...
The life cycle. We'll actually talk about the life cycle after the demo. But essentially what happens is that when you start one, you have the root process of that instance. When it dies, it takes everybody else out in its instance. So you basically want to run init in each one, or just have a vaguely intelligent thing.
And you don't have any way to shut down one from another?
One can have tools to do that, but basically you just kill init. And once you kill init, everybody else dies.
But you have to be in that session.
Well, I allow some tools that go between them, but they all run, and I'll talk about the credentials and everything and how it does that. So it's not like these things are running and you can never touch them. I mean, there are tools to do that. All that matters is how we consider the safety of that, and that we make sure that we don't violate the constraints, and we also don't violate the integrity of the isolation. So what's critical to me is that they're really logically separate, very cleanly, and we know exactly what goes between them. Yeah. That answer your question? Yeah.
How the file system?
Don't touch them, and I'll get to that later. That was horrible bad doing the prototype. Yes?
So, point of clarification.
Uh-huh.
Obviously, all of the individual, for lack of a better term, virtual machines.
They're instances is what I call them.
Okay.
Yeah.
So all of the instances are completely isolated.
Mm-hmm.
From the hardware node, is there manageability into them?
What do you mean by manageability?
You've said that you've created some special utilities to be able to do process lists inside of
Yeah.
them and stuff like that. Is there the ability to drop into a shell inside one?
I'll get to that when I talk about the prototype thing, but essentially what we want to keep in mind is the only thing I'm protecting is struct proc and the struct proc derivatives, and those that are hanging off of struct proc, basically. And PGIDs also. So, go ahead.
I'm thinking of it from the standpoint of, okay, so I'm a hosting provider. I've got 10 different clients.
You'll love the demo, by the way. I'll do SSHD. So, anyway, that's actually a very good question, and that was a major issue of contention when writing the big prototype. And things like, if I want to start a shell in it, how do I do that? Because a shell would inherit a file descriptor. I can't inherit file descriptors in the new instance, and so on and so forth. The chicken and the egg problem of when it starts up, who gets the device list of the terminal, whether it's a sudo TTY. Those are really complex things, and we'll talk about them a little bit after. I also don't want to run over, and I probably will, which is, just deal with it. Yeah.
I've answered this before.
Mm-hmm.
Just quick, if you have segments that are not shared,
Mm-hmm.
all forecasts today.
No, I ignore those. I ignore all. I mean, fork 1 accepts a lot of flags, and fork inst doesn't. So it doesn't do things like allowing you to share a copy on write or whatever. It's all from 0, essentially. So I think some, and we can look at the code later if you want, some things are copied in, but memory may be copied in just for the newly forked instance, but no resources are. And there's a kind of fine line between that, and we can look at the code for that later. I just don't think most people are interested in the actual, technicalities of what's being memory mapped and so on and so forth. So we have to talk about it when we're not boring people. Because when people fall asleep at a thing you're giving, it's a horrible feeling, and I'm trying to avoid that as much as I can. All right, so let's talk about 4-over conference call. Being told to make that go away.
Oh, no, you're fine. Just hit the little X thing in the window.
This little X thing?
No, inside the window next to the
Oh my
window.
god, there are 2 X things. Alright. Yeah, I'm really not good with these things. Oh, and I lost my connection. So let me start this back up again.
It's starting right now.
Oh.
It should be up. Yeah, you want to increase the terminal size?
Yep. So the way I'm doing this is a little bit funky, where I'm connecting to view, right?
Yeah.
Bigger. And that didn't do anything. Bigger is better.
How's that?
Can everybody see that? I can't either. It's about 100 letters, so don't worry. So the way this is working, ignore what you see on the screen. I just made it say that. Is that I have, because I'm paranoid, I only let in by pub keys, so I have to connect to my server in Riga, and then go from Riga to Sweden. And then I have the system running in a QEMU instance where I do all my testing. So I'm going from here to Riga to Sweden through a QEMU and then to a telnet server that emulates a serial. Right. So this is the actual system itself, and I'm going to reboot it now so we can all see things from the get-go.
It connects to your laptop on the table.
Oh no, that's too far from me. I can't.
Are you doing a reboot of hardware here? Or
This is a reboot of the actual the computer that's running. So this is the instance hardware, the virtualized hardware. Okay. But I just wanted you to see it. This is it starting up. This is a patch version of OpenBSD, my local branch of OpenBSD, starting up now and doing all of its good stuff. All of this is vaguely familiar. Yes?
This sounds really, really cool. Why has no one accepted your patch?
You're jumping the gun. All right. We talked about this. So, damn it. All right. We're gonna have questions later for some people.
You didn't have to call on me.
I'll yell at you later. All right, so here we go. This is, for all intents and purposes, a completely normal OpenBSD installation of 4.4. Right, so nothing there is, I mean, you can have me run things if you want. Everything is pretty normal. All the normal stuff running on it. I don't think anything here is special at all, actually. Essentially, what is installed right here is a download of 4.4, run a patch over it, did all the make, build, all the stuff, install it right like that. There are some differences that we see already, though. For example, I can't use less, by the way, because this is a telnet, so actually that won't work. PS, for example, has an extra flag -I, which lets you see which instance into. This is instance 0. They're random after instance 0, and I'll get into those problems later, which is exactly the same. So right now I'm actually running in an instance from the get-go, and that is the 0th instance. And there's nothing special about it at all. So I'm going to bring up two tools that are bundled with this, inst-ls and inst-proc. Inst-ls shows the instances that are running on the machine and how many... What's that? Oh. So this little tool, it really doesn't do anything except show what instances are running on the machine. There's only one, and it's got 6 reference counts. I can go into lifecycle things and reference counting later, but basically, instances exist as long as they have a reference count above 0. Once it hits 0, they're over. Reference counts are cloned when I think ucred is cloned or something. I don't recall exactly, but all of that hasn't changed in the past few years. That was how it started out. So I'm going to just jump right into it and do something awesome. So basically, SSHD here is a normal SSHD instance. It has the normal configuration, except I can log in without a password with root. Yeah.
Were you running that as root and can only root run?
We'll talk about permissions later. But for all intents and purposes, this is just root for now. Users are the same across. They're totally unscoped. So users are as they are right now. Inst-proc, which is a stupid name, and I'm sorry. I probably brain farted. But inst-proc starts up a new instance. And internally, the actual source code, it looks a lot like fork, running fork and exec, except that fork is replaced with fork inst. And I have to do some fancy things to reinstate the file descriptors for standard instead of there. But you can actually look at the source. It's very, very simple. And I'm going to do exactly what that... Yeah, just because I'm going to have a dash at the end, and it used to be cantankerous with that, and nothing happens. Except, if I look at inst-ls, there's a new instance running in there. Now, I cannot see it. So as you can see, SSHD is not running at all, right? It's not there. However, if I SSH in a localhost, it's there. So this is the same computer. All that stuff is still in there, but I can't see any other processes than the ones that are there right here. There's nothing else that exists in the system. So from my system's perspective right now that I'm logged into, nothing else exists. Just these guys. So if I log out, as you can see, everything is back there. But the SSHD is not in there. And just, for completions, don't die. I actually don't have a reason to think it'll die. I ran this demo about 1,000 times to avoid embarrassment. I'm pretty sure it works. Is that fairly self-explanatory? Do we all kind of see what's going on there?
Can you do an installation?
So this is the one I'm in right now, and this is the other one. So, go ahead.
I don't know if it's interesting yet. Why do you have 2 reference guns?
I think it's because it has the process, and I could have like a select event that's running in there. Because select events are independent of the process. And again, we can cover that later, so that might be a reference count there. There should be later an inst-ls that actually shows you which subsystems have allocated reference counts. So whenever I allocate a reference count, I'll get you guys in a second, you know who is allocating that reference count. So I can say, well, select info has a reference and ucred hasn't, which is probably something like that. because SSHD is listening. So that could be it. Previous versions of NetBSD 1 had that, and I just went for simplicity here. So this, what you're seeing here, I should mention, is the bare minimum of everything that could be on this. It's the absolutely bare minimum for a reason, again, that we'll get into a little bit later. We had 2 questions in the back. I'll start with the guy on the right.
The InstLS, is that a global list of all the instances?
Yeah.
And you can run that from within it?
Yeah, for now, yes. And we'll talk about a lot about the security and the inter-instance security a little bit later. But for now, I have places in the code that say this is where stuff should happen, but I let everybody do everything just so it's a cool demo. Yes?
So that SSHD 12.4 and 7 there, the root of this instance, so if you were to kill that, it should take out that and all the instances and drop you back to the one that started it.
So here I am in the instance itself, and I'm going to kill my parent. Let's not get excited, though. I mean, I see a lot of people getting crazy eyes. Over. It's gone. So I killed my parent. I said that. Now people are actually looking at me threateningly. And it's over. It's completely garbage collected, killed. And what happened internally, which we'll talk about later, is when I killed the main... it should handle that basically, like in a init. But this doesn't do that because it's for it's a simple program. But if I kill it and it dies, so it's actually in exit in the kernel, it will kill all the processes that are running in it with sigkill, and then wait for them to exit. If they don't, like with zombie.io, it'll wait forever. That's kind of a problem that all systems unfortunately have.
So could I make a user shell instproc KSH?
Yes, but you wouldn't be able to see it, because we can't inherit the file descriptor of the parent. So that's something we'll talk about with like terminals and multiplexing later. But basically, when it starts it's completely gone. So you can do pseudo terminals, but you can't access your own terminal because that would in turn inherit the file descriptor, and we can't do that, which is why I use SSH. And I'll also do an HTTPD example in a few minutes too. But basically, this is the cool one. Yes?
When you kill the root parent, who waits for it? You reparent it in it?
What happens inside of it, and this is different from the NetBSD version, which handle exiting differently. In the OpenBSD version of this, and I'll get to the differences between these a little bit, when you kill the parent and it's in exit, so exit 1, it sees it as exiting, and before it releases itself completely, it waits, it sleeps, to see when all the children have either exited or are zombies. And then when they all have, then it reaps them, and then it continues running and completely exits itself. Because if it exited and there were still children, then you'd run into leave group and enter group problems, where people try to do session stuff, and of course their parent is dead, it's null, race conditions exist. So I try to avoid all those race conditions by being a little heavy-handed, and it just waits. So when it's in exit, it sleeps, kills everybody else right before that, and just waits for them to zombie.
But nobody waits for SSHD?
No. Once SSHD is dead, it's the instance is gone. It's completely tanked, very reliably too. And in fact, and I want to see who under jail used to have problems with killing jails. I've heard about this, right? So this will never be a problem with this unless you have I/O that's hanging forever. And that's really not something that's our problem. I mean, per se, it's the kernel's problem. And I believe in NetBSD, at least, there was talk about this a few months ago, but of course it went nowhere. So, yeah. There was talk, right? Talk's cheap. Yes? Yes. Maybe, I don't know. There may be issues with that. I used to have issues with when I have asserts everywhere. I love kassert, but with the ownership of the socket.
Because if you have that, you have the file descriptor through the Unix domain socket to get it.
You can't do it because all file descriptors are owned. Well, it depends. If it's a select event in a file descriptor, those are different. Select events are independent of the actual process itself, so they're keyed by the instance that created it and the process of it. And this is getting a little technical, so sorry people are getting bored. But that we can talk about a little bit more, the differentiation between select events and file descriptors. File descriptors are safe. They're appropriated just like everything else. Select events are independent, so that's why I think why that reference count is in there. So if you open up a Unix domain socket and attempt to transfer the file descriptor, it just won't let you, because you're trying to transfer it to something that doesn't exist. And you can't get the file descriptor between them in the first place. So it just won't. It wouldn't work. It would be like no.
Am I not missing in processing? You're not dropping privileges and any of that stuff?
I'm not doing any of the good security things in the user land for now. And this in the code again, there's actually a very small impact on the general code where security things take place. It's all in one file, kern inst. So we'll get into that after I do the demo of the trailing part of the conference itself, talk. So let's start it again, just for obviously it doesn't exist anymore. And so here I start again. Now one thing to notice is that I was able to, the first time, log out of the instance and log back into it. So again, what that means is that I can kill processes inside of the instance and it behaves just like normal, but if I kill the root, then it's all over. So that's a really important thing. All right. So let's do the other example I have, which I think is fairly relevant. I know you don't need the double dashes, but it's like I need to do my thing. You'll notice, by the way, that I ran SSHD with -D and I'm running HTTPD with -X. That is because if that initial process does a daemon call inside of it, it forks, the parent will exit, which will cause everybody else to exit. So, I mean, yeah, I could solve easily, just have a little dummy in it, but I didn't want to write it because I thought this would be a little simpler and true to form.
Kind of fake in it, but that's easy to see.
Yeah, and that's what I did with the NetBSD one.
SSHD processes.
Yeah. No, I didn't. I mean, kind of deliberately.
Yeah, of course.
Yeah. So inside of.
But it makes sense. Right?
Yeah, in the initial in the inst proc. I have no idea why I called it that. Sorry. I apologize for that. By the way, I get carried away sometimes. And I just inst proc. I mean, but usually they start with inst. So anyway, for the NetBSD one, I had inst-init. And that was basically a simpler version of init that did all the correct signal handling and reaped all its children and everything. Inside of the manual pages, and of course everything is a manual page, it says very clearly what the caveats are, that you must reap your children or they're just going to hang out there, and so on and so forth. So if I were to run this SSHD instance enough, the zombies for the SSHD process, if there were sub-children of children that got zombied, would just stay there forever.
So does your reference count go to 0 or remain?
When the reference count goes to 0, that's when everything has been reclaimed and the instance is over.
So, but if you have zombies, it won't go to 0.
Yeah, it won't go to 0. So because the zombies are still there. So the zombies will make sure it never dies. So again, a big thing is. Any more talk of zombies and killing and dying and parent, killing this. Yeah, it's just, not only is it freaking me out a little bit, but there's a fork one also. None of that. So again, I have an HTTP there. I'm going to really quickly run this because this is not nearly as exciting as the. And I can't use links because again, the terminal will get all messed up. Nope. No, that was intentional. Right, so it gets the actual. Basically, the HTTPD run instance is running inside of it, and of course, it's not doing all the fork stuff. And if I were to use some fancy CGI to see my processes, just like with SSHD, I would only see my local parent. I wouldn't see any of the other guys. So if you're running like compat Linux stuff is actually a big, where do all the vulnerabilities come from? Let's be serious. That and mailing lists, then nobody can see anything else. It's nice and clean. Everything is separated.
Do you have a way to show actually what's in that jail? So can you?
Yes.
Can you show your PS with -I, right?
Yeah, my PS-I will actually show all it is a tiny augmentation that changes the sysctl.
Right.
And the sysctl, I have 2 or 3 more sysctls that do instead of kern proc2, it's kern inst proc2, lets you pass in an instance also. So I don't want to change any existing stuff. It doesn't work with nlist yet. So that's just complexity I don't want to handle right now. I forget how to do the copy and paste thing, so hold on. Let's just do this.
That'd be really fast.
Oh my god. I'm trying to do this.
So that's why they were 16-bit originally.
Yeah. There you go. So there we look into that. And of course you can't see the full path of the command because... Oh yeah. You can't see the full path of the HTTPD because inside of PS it's doing a KVM lookup after that. And of course it's trying to look it up in its own instance. It doesn't exist. So that's why it shows it like that. But all this stuff it gets directly in kern inst kernel prop 2. Question?
File system isolation, is that coming?
We'll talk about that after. File system isolation is probably the most painful thing in the world. And we'll get in when I talk about the trials and tribulations of the prototype. That is one of the heavy things I'll talk about. It was so ugly, but I've got some fancy stuff that's coming out for that. You'll love it. Yes.
When you call fork inst,
Yeah.
in the parent, do you find out what the ID
Yes.
is?
Here's a quick example. Jesus, will it does a p lookup. See, so you can look it up. That prints out also its ID, so you can know that. Of course, it's just a number. And again, we'll talk about how you can find the instance process from the number and everything. That'll be in the security part. Before I jump out of this demo, does anybody have any things they want me to do? Hopefully really nice things.
Pat your head and rub your tummy.
Yeah. I don't have a tummy. Tummy?
So
Jesus.
when you wake up,
What's that? it should be.
Wake up, your dad is molested, right?
When I wake up, what? Wait a second. What?
That's right. When you wake up, you're dead. Right.
With a sleep.
Oh. Oh, right. Yeah, exactly. This is something I'm never, ever going to show anybody else ever. Not only it's when you sleep, you wake up and you kill your parent, and he dies, and you die also. It's really, the potential, marketing for this really needs to be heavily considered, and I should never, nor you should never do that. So, filtering all email messages in the future also. Question, yes?
So can you kill the process from the parent?
I don't have this in this installation, but kill also should have a -i. But I get a little worried about changing kill because it's such a basic thing. But it operates under the same principles, and actually in the code it's very simple. Or it tries to grab a handle to the instance in the kernel, and then it just sends the init process a p signal from internal. So it's very simple. Yes.
There was talk of file system isolation. It occurs to me, why not just run your first process and not run an instance in chroot?
But chroots are weak. That's because you can't run a chroot inside of a chroot. And in that case, we're just it's a way of doing it. In fact, that's what I first did when I had the NetBSD prototype. Is inside of the init, inside of the pre-fork into an inst, I just ran a chroot and a chadir. But the problem is that nobody else can do it, and it's just it's ugly, it's hacky. And the whole point of this is to be as very simple and elegant as possible. And I would rather not have an extant chroot just hanging around.
And it's also very weak.
Yeah, I mean chroots,
It's weak.
it's weak.
Yeah, it's not a security mechanism.
No, it's not. It changes the roots. It's very simple.
Namespace, not security.
Yeah, I mean that's the whole point. Chroot changes your root, nothing else. It's not there to protect you from zombies or parent killer.
So how many instances have you tried running on?
Several thousand. Basically, it's just a process. There's very little in there that is that's happening that's overhead. So starting an instance is pretty much instantaneous. There's very little overhead, with the exception of the copying over of data. So it's like you were to start a new process completely afresh. There's actually no more. Same with shutting them down. With the exception of the init one waiting for its children, shutting down is exactly the same.
When you say copy and write on this first half of this talk, when you say copy and write, what are you talking about?
Things like copy and write or shared memory, text segments and data segments, internal.
Libraries aren't shared between instances?
They are. Wait, no, they would not be in that case.
So if I run a few thousand instances of stuff that includes something like fat new C, then would that?
Actually, I don't think that would be. I don't really think that would be a problem, but I can't answer that right now because I'm going to speculate. So I'd really have to look into that. Put it this way: if it is a resource like an open file descriptor, it's gone. You're not going to get it. Everything else is copied over. So if it's something that could conflict between instances, it won't be touched. When you actually have the fork, and this is right in the code itself, when you have the fork inst, it does run fork internally, and it just passes in the default, don't share anything. And that could probably be changed in later versions. This particular one, like I said, it's as small as possible and as auditable as possible. We'll talk about that in the second half of the demo. I saw a few other hands being raised. No? You guys, I can turn this off. Hopefully it's not going to bail out right now.
You can kill that.
Yeah, alright, so...
I'll sleep for a little bit and then
Sleep with the process. When shutting down, by the way, everything operates the exact same way. If you were to try to run reboot from inside of an instance, I think the reboot program, before it actually tries to reboot, tries to kill the init process, so it would just die. And I'm not going to test that. No, don't ask. Yes?
Can you run a top inside one of these?
No, because the terminal is going to get all screwed up.
Okay.
But basically, top uses sysctl to get its values, or kvm endlist. So it would just see its own. But I can't run it because the terminal would just get all screwed up.
Could you top it and like pipe it through something so that we just get the one?
Yeah, sure.
Just to make him happy.
Type. Can I do that, or is it the cursor's going to mess that up? Okay.
Again, it's not a
What am I like that? And into what? Just CAD? Oh, head. That's real exciting. Let's see if we can show.
Hold on, I'm showing the backdrop, so you should be in the cat.
But it's fine the way it is.
Yeah, I mean, I guess we can see here that it's not running any of the, what was the other, SSHD and HTTPD are not running in it. So, I mean, top internally just uses sysctl. All the sysctl stuff is obviously protected. So, we can run as many things as we want that show processes. Internally, in libc, they're all going to go through sysctl or kvm anyway. So it doesn't really matter what you show. They're all going to show this. I mean, but I can run other stuff just because it makes me feel kind of cool. Like, I already thought of that, babe.
You'd have to modify top though, right? If you want to show the...
Yeah, I would have a -I also, I guess. But we'll talk about the security. We probably don't want to do that because it would just mess it up a little bit.
Right.
All right, let's jump back into the...
I'm perfectly okay not having any -I options.
All right. By the way, this is it's completely clear to me. File. So nice. Okay. So let's move on. So this is the history, a brief history of this project. The first public release was in 2007, actually, and that was NetBSD 3.1. The whole kernel on my local branch I forked. It was enormous, and we'll talk about what was in there, but basically I appropriated everything. So if you ran mount when an instance, it actually booted formally. VFS booted internally inside of it. The initial process, the initial instance, was just like any other instance. So with this, it still is, instance 0. There are some little problems, and not problems per se, but little special handling. Very, very little. But in the NetBSD one, everything was completely isolated. It was a nice piece of work, but I ran into some major problems. I actually proposed it to the University of Latvia in 2007 as a project, and they said no. When I went to KPH, they liked it and they kind of picked it up. I presented it at Stacken. I think Arla came out of Stacken. Heimdall also came out of the same area, so a good bunch of guys. The big presentation was at Asia BSDCon, and the whole presentation was bashing jail. Actually, is what it all comes down to, and why this is awesome and why jail was bad. And I know BSD people are really looking at me right now. But the reasons I think are pretty clear. That's you have functional isolation or logical. Functional, you're always going to be looking for the next thing that could be broken into, and that doesn't work with me. It's not security as it should be. I started to port OpenBSD-4.4 almost when it was hit in RCS. So the instant it was tagged, I jumped on it. And the reason I did that was because NetBSD 3.1 was outdated almost when I started. I just wanted something stable to prototype. So that was in the end of last year. I talked very briefly at Slackathon about this. It wasn't ready then. At that point, I was just working on it. So I talked about what it was. And then since then, I've just finished. The NetBSD one, actually a little bit before that started. And the whole purpose is to have a NetBSD and OpenBSD API be the same. And we'll talk about that a little bit later as to why I did that. So the system calls are the same, and obviously the front-end calls are also the same. So that, I think, is a very useful thing. the more homogeneity we have between the systems, the better, and especially for something like this. So that's a big push. And obviously DCBSDCon is now. What this roughly translates into is that I began with NetBSD, full system appropriation. It turned out to be way too heavyweight. We'll talk about that. I mean, I went way over my head. OpenBSD, the whole purpose was to have a tiny patch set, which I more or less have done. Getting ready for your question, Jason. Yes. And NetBSD one I started recently, and it's very straightforward because I already did the heavyweight one, so I'm pretty familiar with what's going on in there. Issues. Here's the fun part where I get to... So performance and security are the two big issues. Complexity is also a big issue, but we'll talk about that a little bit later. And the biggest one that's always talked about is that when you have one process table, things are fast. When you have n process tables, things might be slow. And it's a simple matter of looking up. Because every time you look up a process, you have to go through an intermediary. And initially, I had process tables in dynamic memory. So it was really slow. I didn't understand why. It was just a bad day. But for the most part, there are a couple of ugly solutions to this, where one is that all the dynamic memory that I had, I pegged in memory using pools, which increase the speed of it a lot. So instead of having each subsystem has its own little dynamic memory that can have its own stuff in it. And it's all anonymous pointers, so it's very easy to, and that I'll talk about later too. It's very scalable. But the problem was that I was allocating those in malloc, and every single time I had to look them up, there were issues with that. I put them in pools, it was a lot faster. Another thing that I did, and this is a little bit bad of me, but it actually worked a lot faster, was originally I had separate process tables for everything. That got slow when I had several thousand instances, really slow. And I thought to myself, well, I can peg the size of the process table so it's small, and I did that, but it was still slow. So I faked it in the end, is I have one process table, and there's a flag you can define, global hash, that turns off this feature or on this feature where you're either using per instance process tables or not. This is a hack for now, until a better solution is found, which is, of course, there are lots of other ways to do this. I just really didn't want to spend time on the speed. It wasn't that important to me. As long as the API is there are ways to solve it, and I'm not an expert in these ways. Other people are, but the solutions exist. So the performance is pretty much all just memory speed, is that lookup. And it can be solved, and there are several ways to do it. The question is how to do it without violating integrity. In fact, the one table and having per instance things there works pretty well because the area where you have that possible contamination is just 2 lines in the entire system. So it's very clean.
Kristaps, is this really an issue or is this more a perception issue?
It's certainly an issue. Things were a lot slower. I mean, compiling the kernel took a lot longer.
Really?
Yeah. Because of, I think also another thing is in SCED-BSD, it loops over all the instances. And there are probably ways to tweak that also. But again, that's not my concern. I just wanted it to work and be very clear. You guys can figure out the rest. Not my problem.
What I mean.
Then you, the Windows guy.
The approach is perfectly fine. That's the only way you have a chance of getting that into a BSD. So
yeah, it's as simple as possible. Correct. So this, of course, is the really, really big deal, is the security of it. If I don't have the security, I might as well be jailed. And I really don't want that. So getting between instance I and instance J, that is all that is really important to me because that happens. So there's a function there that maps between instances, and it needs to be good. It needs to be really good. The times we have cross-instance pollination are as follows. In the scheduler, obviously the scheduler needs to see everybody. When we're doing the PS, right, and I want to see read-only into another instance, there's another example. When I want to kill things in another instance, there's another one. When I start another instance, all these things need to be handled. And in fact, they are. My examples are PS and kill, insproc, and so on and so forth. There are 2 functions that are exported to the rest of the kernel, right? There's instfind and instget. Instget, it's a dumb name I just grabbed from crget. Starts a new instance, allocates it. Instfind looks one up. Those are where you have the possible contention. The other one is where you get the list. And that's even simpler because only one thing uses it. So at that point, there are a couple of things we could do, right? We can have an administrator say this instance can see it, that instance read only for these functions, and so on and so forth. To be honest, I really don't care. I just set default deny for everything. But there are a lot of opportunities for this. What's important is that all of that logic is in one function or two functions. All of that cross-pollination logic is just right there. And there's a simple to-do, protect. And actually, I don't deny. As you can see, I do default allow if you're user 0. Very, very simple. The status of this project. The OpenBSD one is that's what I've been using right now. In fact, internally, OpenBSD is a little bit simpler because it doesn't have the locking issues that NetBSD one has.
And the transparent background.
If I were to say that was not an issue, I would be lying, right? I'm a very petty man sometimes. Everybody knows that already, right? That's how it is. Transparency important. You'll notice that this one is over the NetBSD one. Why is that? Because of the white background. Don't flatten your images. I'm just saying, right? So the OpenBSD one is a lot farther along. Getting the NetBSD one up to speed is really easy. It's not rocket science anymore. The issue with the NetBSD one was killing processes. The OpenBSD one is a little bit simpler in that regard. It has a Reaper thread. NetBSD, at least in 3.1, and I think in 4 also, in 5, I'm sorry, does not have that. So there was a little bit of magic that had to occur waiting for processes to exit. I didn't like that ugliness, so I flipped out to OpenBSD. But writing it is very simple.
We get many developers that way.
Well, it's not a joke. That's how it goes. And it can be fixed or not. And it's not fixed yet, so I didn't do it. Kill parents. So the NetBSD 1 is getting done, and it will be done pretty soon. This is really not that hard now that I did the 3.1 prototype. So it's really not that complex. My goal, which is very easily realizable, is to have the same API for both of them. Not the kernel one, although it will be by coincidence. But the system call API has to be the same, including the sysctls and everything. And that's done. So, again, with the intention of somebody being able to just run intsproc in both systems, not have to worry, do I have an I flag here or not? So that's nice. Right.
Well, we'll want you to put that all in one utility called inskill.
Oh yeah, inskill. Kills.
Control.
Parents. Yeah.
Nevertheless.
So this is, I think, the most important part of this, is the lessons learned thus far. Again, it was started in 2007. A lot of bad things happened. It started out really nicely, and then everything hit the fan. File system appropriation has been brought up several times. It is really ugly in there. So ugly that I gave up after a while. And the problem was that really deep down inside of the file system, you had comparison of things like PIDs and for permissions and that sort of thing, really far down that call chain. And if I wanted to change that to encompass an instance, I would have to change all of that call chain out there. And I tried that by hand, and I just gave up. But it was coming along, actually, somewhat nicely. What did I get running? procfs I had running per instance pretty easily. And a few other of the FSs. The pseudo FSs were pretty easy.
Another reason for using OpenBSD, no procfs. Right,
that's true. But it was pretty ugly, but it's doable. Now, a nice little research project that a student of mine is doing at the University of Latvia is to write a pre-processor scanner parser for C that creates a decision tree of C code before it's been pre-processed. So with that, you can construct a very nice abstract picture of your source code, change function templates for everything without loss of generality. Very nice. So that actually might be something that we can do a little bit more automated in the future. And all it takes is a little bit of automation in this regard to make it a lot easier. C-scope does not do the trick, because there are hundreds and hundreds of them. And I tried, so it's really not going to happen. Network device appropriation is another thing. There was a big question of, I can get physical devices for hard disks by, say, vmconfig and start an instance off of that. That's what I did. But the network device is a lot more difficult because they aren't virtual network cards for Open or NetBSD, although FreeBSD, I think, had them. So basically, I had to bond to a real hardware device. And, that doesn't work.
That's a simple problem to fix.
Yeah, but it was like the routing tables. I didn't want them shared. I basically wanted to be able to run DHCP from it.
No, so what I meant was you can write easily a virtual network.
Yeah, but I didn't want to do that.
I don't have that.
But you can have it with new things. But That's an easy problem.
Yeah, these are also more future problems because right now all we're doing is processes.
Right. Well,
if we want,
solve all the other stuff.
We'll work on the other stuff.
Here's the neat part I'll actually get to in a few minutes. The chicken and egg was also big. Who starts what? When the computer boots, what happens? I mean, something has to happen. And this is kind of more of a philosophical question than anything else. There's no technology here that's interesting at all. But it's just a matter of the security policy of it. And frankly, I think if we could provide the tools, let people figure it out themselves. The fun badness was great, right? What happens if you have thousands of instances starting up within the space of a second? Because they're basically like a process. How do we handle that with DNS if each one has their own virtual network interface card? DNS has to be a lot faster. DHCPD has to be a lot faster. The management of these has to be good. I have to let everybody know that I work in a high-performance computing center, so we really care about very high-speed things. Zen taking, 4 hours to start up, I think was my last benchmark, does not work with me. I want milliseconds or faster. That's what this does, but the tools kind of lag. If I have thousands upon thousands of instances and 10,000 chips, that's a lot of instances. So all these kind of bigger management problems come into play. The namespace of instance identifiers, for example. But all that's really easy to do. I mean, it's not in the kernel technology. It's kind of outside of it. If we can provide the tools, that's fine with me. But there are some really nice things that came out of this. Once the framework is in there, and that's pretty easy, appropriating new things is very iterative. So you can have the system, have it work, just like with this processing for a while, and then very slowly add in a new thing. For example, if I want to add shared memory to here, and that's the deal with FreeBSD jail, what do you do with shared memory? They've got their weird flags for it. I don't like that at all. So we should be able to add that in very slowly after the system is already stable, test it out, let it keep on running. That's really easy to do. And in fact, in the kernel, the actual API for it is all anonymous pointers. So everything's very easy. It's very configurable. The base framework, basically, once it's there, everything is very modularized, I think is the cool term, but it's just anonymous pointers is the literal term. So this is the kind of jail-like system, which is not at all jail, that is very easy to implement an initial one that works and is visible and does cool stuff, and then very slowly over time add in even cooler things like virtual network interface cards or virtual hard disks and all that sort of cool stuff very easily. That's all I have to say. Thank you very much. Thanks again to Jason. Questions?
Yeah. Hey.
Yes,
this is
you
such
in the
a
back.
really cool technology. Why has nobody adopted it yet?
I don't know. Actually, I've never actually gotten an email about this ever. It's been around for about 2 years. So there's a patch. If you go to the website, I have a diff against 4.4. It's just sitting there.
No, wrong approach. You have to send the minimal patch in about 4 weeks to the tech mailing list.
All right, so
4 week party.
and then I put on my asbestos mask, right?
4 weeks, not like 10 or 4 years. 4 weeks.
All right, well, I can do that. But it's all. I mean, if you guys want to look at it, I have WebCVS there. I mean, it's everything that should be.
Merge all the utilities in an inst controller, inst kernel.
That's actually what I had at first, and I stopped liking it. I don't know. I mean,
that's the only
so
way.
The word of less is not going to fly.
Yeah, the less of a patch. That's easy. I just wipe the PS stuff. Excellent. Well, that's doable. But it really does any question.
Do you actually have you adapted any application suites, like stuff like mail servers?
I don't need to adapt anything. It just works out of the box.
What I mean is to actually show setting it up, running it. Because at the moment, I mean, it looks cool, but people are going to go, well, how is this going to work if I drop this on my mailman installation? What does it give me?
To be honest, that is really, this is actually an interesting point, is this is a sort of system that people aren't very familiar with in the concept of it. I mean, except for jail, we don't really think that way. And very nicely, the guy who runs BSDLV, Dexter, he has a site out there called multiplicity.bsd.lv. And there it has tutorials of doing this sort of stuff and what it's like to run them. I would rather somebody else do that because I'm really not good at... I'm a really terrible user, in fact. I had difficulty running this because I had to point and click, and I got confused, and it's not a joke. So I'm really bad at that stuff.
This is the thing why jails work reasonably well, is because they just mostly, except for loopback interfaces and shit like that, they look like a normal machine. So it's not a large leap.
Oh yeah, and it does look like a normal machine, except that there's no
Except that
process
there's no
one.
network interface. Like, for
Yeah,
example,
for now.
how do I stop a process at the moment binding to port 80 of your machine inside a prop?
Oh, you mean if you have an instance with port 80 open and you want to do the same in another?
Yeah.
You can't. It's a flat namespace.
Right. So
Yeah.
I mean, at the moment, people are like, well, what's the point?
Exactly.
So that's
Yeah.
why I'm saying. Like,
Yeah, but this
your
is-
adoption problem is step one. There's no example.
It's just another system to
One
program.
driver away. That's
Yeah.
exactly
So,
what I
yeah,
said.
but again, like you're
Yeah.
lacking deployment information.
Oh,
You're
yeah.
going to go, what's the point?
Oh, exactly.
I could write the driver in the time it took you to ask the
Well,
question.
then- This is the thing. Like the jail stuff mostly works.
Yeah, it does until you really need it.
Definition of works, yeah.
No.
Well, I mean,
Windows
it's not
definition of works.
for basic virtualization. For very basic virtualization, it works. People solving security problem, not virtualization, not specifically a slice of it.
Well, this is. I mean, the whole purpose of this was a very lightweight little thing just to get the ball rolling. And if people want to add things later, it's really easy to do. And in fact, to answer your question even more, if you guys are interested in this, so this is going to hit mailing list pretty soon. Just do things, help out. In 4 weeks, after 4 weeks. Maybe after 4 weeks, this will be in the mailing list.
So what's going to happen is
Perhaps someone would mail it to
What's that?
Tech.
We're going to try 4.5. So you want at the very beginning of the 4.6 release cycle is what
I
you're
see.
saying.
I see what you mean. Yeah, exactly. So maybe, coincidentally, in 4 weeks there might be an email about this. Yes.
Well, just to comment on his thing about how is this actually useful in production.
You have to speak up a little bit.
Okay, just basically to comment on the earlier thing, like how is this useful in production? The thing I'm seeing that's lacking is just how do I give these untrusted users their own file space? You know, it's all well and good. I can't see your processes, but if I can screw with your files, I'm happy.
There's I mean, with the initial one, the very first thing I did was a chroot.
Yep.
So you can very easily just run a chroot inside of each instance and you're done for a very minimal thing. But the correct answer is that file systems need to be appropriated more or less, or you just have each one have their own device. I used vnconfig earlier. But the problem, not really the problem, is that that's just another subsystem that needs to be appropriated, and that can be done later on down the line. This is the minimum. Processes are the base.
No,
Yeah.
I understand. This is a great research project, and it's a really cool thing to see. But it's not something that you can get a practical buy-in from a hosting provider because
Not yet. No, it still needs work.
You know, it's not a product yet.
Yeah, it absolutely needs work. It needs more bells and whistles. It needs more things. But as long as we have the very basic part in place, that just comes with the territory. It iterates very nicely. Yes?
Have you thought about putting it in FreeBSD?
That's actually a very good question as a FreeBSD. Did you also have that question? Because you're like,
No.
God.
No, I had a different question.
Well,
but
let
I have
me
to chuckle. Go ahead and talk.
All right,
about more.
too complex. That's flat out. It was way too complicated. When I was looking, this was 2 years ago, my first question is, where do I do a prototype for this? Where do I do it? And it came down to OpenBSD or NetBSD, and I chose NetBSD just because I've been using NetBSD for my lectures. I worked as a lecturer at the University of Latvia, and I just was familiar with it, so I could jump into it very quickly. People asked, why don't you use Linux? And I said, which one? Because there apparently are lots. It's like a real number line, right? Between versions.
It's also a 32-bit number.
No, it's really huge. It's
32-bit number.
there was and unfortunately there was somewhat of a problem with that with FreeBSD is that the clarity was not there in terms of what I can use as a basis, what's useful, and I just didn't know it. It's very simple.
The correct answer to that question is go ahead and do it.
Well, I'm going to let him say that. I mean, literally.
Go ahead
The
and
next
do it.
question is going to be,
Yeah.
I looked at what the FreeBSD people are doing in this sort of space.
No.
They're doing multiple routing tables and virtual
Yes, I did talk
with.
with.
To sort of jail becomes something
Yeah.
like on the side where you build the jail functionality out of other things.
Yeah, I talked to Marco Zetz before he went AWOL, or MIA, whatever the term is, and he said that he's starting with the clonable stack in there. His paper was pretty good on it, but it's just it's good, and that can be done later, but it's just so much. There's so much code in there, and I just wanted something small. But in fact, his idea was very similar in the beginning, as having a little pointer that goes off of your process. In this case, the struct prism, and then everything goes from there. You.
Yeah, I saw this. I saw your stuff
And
Michael Dexter showed it to me last year about this time, which
Mhm.
is after your first release, but before
the NetBSD
presentation.
one.
So all of the stuff was in there.
The NetBSD one had everything but simplicity.
Yeah, there were a couple
And
of
NetBSD.
It looked good, but it's like,
Yeah, it was slow. It was a prototype. Yeah.
Yeah, but I mean, having everything federated.
Mhm.
That's
I like that term. That's pretty nice.
Having everything like that,
Mm.
not just the processes, was very cool. Do you see yourself? Is it going to go back that direction?
I think it could.
What issues did you run into with
Just complexity. I mean, I bit off a lot, and the fact of the matter was that it can all be done. It just takes time. I mean, this isn't even my PhD, so I just didn't have the time to change the whole kernel.
Okay,
I
so
tried.
it's a
though.
matter of focus.
Yeah, it's a matter of focus and time,
Not like, this is
But if
getting
you want to get
too
into a
ugly.
project,
Huh?
so if you want to get this into OpenBSD, it needs to be a minimal patch that does exactly this.
Yeah.
Because there's no way in hell that anything bigger than this would ever get in.
Yeah, this is the absolute minimum, and anything less than this, and it wouldn't do anything. So this is the minimum it can do, and very fortunately, once you have proc, there's a lot of stuff in there, and so that helped things a lot. And there are still small issues like, well, DDB, right? We have to change a DDB output so that it shows the instance, or do we not want to do that? I mean, DDB wants to see the whole system, KVM endless. I mean, it's a little things like that came up a lot. I tried to solve them all with NetBSD. I got pretty far, but I got mired in the file system and the network. It just killed me. So that was the biggest downfall.
So one of the real cool things that I can foresee that in the future you'll be able to do this,
Mm.
depending on how you do, especially if you start doing virtual device drive,
Mm.
you'll be able to basically start doing a virtual machine.
Yeah,
Actual virtual
exactly.
machine.
Because the device list is just a list. And that's actually what I had the NetBSD one do before I got tanked up in the virtual network devices, that every single instance had both a mount list and a device list. And you would arbitrate which instances get which object. Some of them could share if they're read-only. And actually it works beautifully because it's already there. It's already a list. All you have to do is change it from being a global into an instance, and it works very nicely.
Then there's more complexity when you start going down the virtualization path. One of the problems with
Well,
jail-
it's not virtualization at all, which is
No,
why...
I
Yeah.
know that, but one of the problems with jail
Mm.
is there's no resource control, there's no jail scheduling. And
Yeah.
you start going down that path.
Yeah, this is actually another very good question that I'm surprised nobody brought up, is management of things like memory and CPU usage and so on and so forth. And the answer is very nice. And that goes that all these values are just global integers or numbers, and they can be appropriated very easily. All you have to do is take it from global, jam it into an instance structure, and then you can play with it at will from there. And in fact, the scheduler is very easy to modify. Earlier, it just ran over every single instance and did its fancy calculation. Now it runs over every process in every instance and does the same exact calculation. So for example, vServer uses two-tier scheduling. I don't know if I agree with that, but whatever. Between its instance, I don't know, whatever they call them, little Linuxes, and does a very simple annealing algorithm there. This can do the same there if one wants, but right now I just kept it as simple as possible. So it's very easy to control those things. You just have to have somebody sit down, look at the code, and find the areas where it's effective. So the quick answer is that these are all eminently doable. You just have to have somebody take a few days to incorporate it. And I tried that with NetBSD. I got very, very far. But after a while, I realized that, this is an old system. Nobody in their right mind is ever going to use it. It's too big to even consider for incorporation. The patch was hundreds of thousands of lines. Not that long, but you get the point. And I tried to kill too many birds with not enough stones. Yeah, zombie stones, right? What's that? Yeah, I'm back to killing. I'm sorry, I got a little fixated with the... So I should go in the frack room for a little while. Oh, the donuts are not going to help, I don't think. Yeah, so any more questions? This is really the time to ask them because I have a tendency not ever to check email because I'm afraid. So I won't answer. Yes, in the back.
Could you elaborate on this aspect of provability that you were talking about?
Yes, that's really the only thing that concerns me is the mathematics of provability. Although my focus is not provability in mathematics, I study game complexity theory. But anyway, so with FreeBSD jail, amongst many other, amongst 20 Snowy Mountains, amongst many other problems, we have how can we prove that we do not have conflict between instances. Does anybody have any ideas how we can do that with FreeBSD jail?
Oh, it sucks.
Well, we'd have to cover every single conflict point, right? Now, it's very easy to say and very easy to see that we don't have that because we do it logically. But I like things that are proven. I mean, that sounds great when I say it in words, and most people are just kind of snowed under, but I really want to prove it. So what we can do with this kind of system is go statically through the source code and look at the actual instance structure. We can say, if you have two functions that take two instance structures and you have a commingling of their variables, that's a conflict point. If you have a global variable that is affected in a function that takes an instance parameter to it, then you're going to have a problem. So I'm working with a student right now. Well, he's graduating. I guess I'm going to pick up his mess. But in being able to do that programmatically, and basically running a program like lint or whatever that is able to prove that this function or this variable is only affected by one instance at a time. It can be done. It's just a little bit difficult mathematically because you have to do a semantic analysis of the parse tree, and that can take the age of the universe. So it's a little... And the big issue with that actually was not... I mean, we all can intuitively understand doing that, but the problem is the preprocessor actually screwed up all of that because the kernel source code is so preprocessor oriented that, you know, for example, we might have it working in AMD, but there could be something in an i386 branch that affects it, and we would never know about it. So that is something that is underway. But you can ask me afterward for a little bit more detailed information on it. But a student of mine is doing it. He's graduating now, and his master's thesis was parsing of unpreprocessed C code into a decision tree. It's pretty cool. Yes?
This tool for proving the conflict points, would that be useful for identifying places in the kernel that need locking?
Yes, probably. Because you'd have... It basically finds race conditions. And it's just a different term for the race conditions. That's a big... Oh, of course. It goes without saying that all of this is using the 2-clause license. I mean, all of my stuff. So, including my students also. Talk to me later if you're really interested in that, but that's a really, really, really hard mathematical problem. And I'm just lucky because I have the supercomputer at KTH to do it.
So is writing threaded code. I mean,
is writing what?
So is writing threaded any kind of really...
Yeah, I know. That's... I work with that. All right, so back to precisely this. Do we have any other questions before I... although I like Jason's question the most. It's $40. And when this gets posted to the list, if you're interested, just write that you are. If you find things that you want in the code that are errors, mail me.
Do it yourself.
Yeah, fix it and send me the patch, basically. It's all up there for you to look at, so look at the website whenever you guys have internet connection.
No, coming. What's your MAC address?
000. Yeah, so that's it.
Cool.